Hello, is my screen visible to all of you?
Yes, sir.
Yes.
Okay, okay, nice. Okay, some people are still joining. No problem. Okay, so good evening, everyone. Today I am Paul. I'm a PMRF research scholar, and I will be a PMRF TA for this course, Introduction to Machine Learning. And this course is originally taken by Professor Balaraman Ravindran, Professor and Head of the Department of Data Science and Artificial Intelligence, IIT Madras. So, my style of teaching, I will be first covering some of the important aspects that is covered in this week, and then I will discuss with you some of the questions that will be very helpful to you whenever you are solving. Okay, someone is joining. Okay. So yeah, so I will be first discussing some of the important concepts that is covered in this week, and then I will discuss with you some of the questions related to this week's discussion that will be very helpful to you whenever you are solving your assignment problems. Okay, those questions will not be exactly like your assignment question, but it will be similar to that. So whenever you are so whenever so whenever you are doing your assignment, you will be you will find it helpful. Okay, so starting with this today's discussion. So our topic or our course name is Introduction to Machine Learning. So first of all, we will know what is machine learning. Okay, so machine learning comprise of two words. Okay, yeah, machine learning comprise of two words. One is machine and there is learning. Okay, so what is learning? Learning is acquiring or gaining something out of experience. Now what is that something? That can be knowledge, that can be skill, or that can be anything. So that is learning. And machine learning, machine is learning the task. Okay, so we will okay, again guys are joining. Yeah. Yeah. So, what is machine learning? A machine is said to learn from experience with respect to some class of task. Yeah, it will be given some task. It will learn. Okay, what is learning? Learning is gaining from experience. So that is learning. And how we will judge that? We will judge that by a performance measure P. Okay, if the learner's performance at the task in the class as measured by P improve with experience. Okay, so learning is what we are gaining something, but when our task will be successful when we are improving at that gaining the knowledge. Okay, so that is machine learning. Now why it is only machine? Earlier we are introducing this machine learning only for computers or machine, but now it is also for biological agents also. So we can say a machine or agent is said to learn with experience with respect to some class of task, and we will measure it by a performance measure P. okay, and we will only say it is learning something if it is improving with experience. If it is not improving with experience, that is not learning. Okay, so this is machine learning, and this term is first coined by Tom Mitchell in 1997. Okay, now machine learning paradigm, there are three types of learning in it. First is supervised learning, second is unsupervised learning, and third is reinforcement learning. So what is supervised learning? Supervised learning means when you are given an input and when you are also given an output and you are learning from it. Okay, again guys are joining. Okay, so in supervised learning, we have both input as well as output. Okay, and we are constructing a model out of that input and output. So by that we are calling it supervised learning. That is learning with the help of teacher. That means we have an output for a particular input. Okay, so that is why it is called supervised learning. So that is first thing. Now supervised learning consists of two tasks. One is classification and another is regression. Okay, classification, when we are classifying something like whether it is an apple, if we are given many fruits, whether it is an apple, whether it is a banana, whether it is something, that is classification. Now regression means when you are given input data and output data, like with number of days, what is the rainfall. Okay, so in that task, if we are predicting for 5 days, it is given what is the rainfall. X-axis will be your, like x-axis will be your this is x-axis and this is your y-axis. Okay, so x-axis will be your will be your time or day. Okay, y-axis is your amount of rainfall. Now we are given 5 data points, x1, x2, x3, x4, x5. Similarly y1, y2, y3, y4 and y5. Now we are now this machine learning task, it will find a relationship between this input and output. Okay, and it will construct a model. Now this model, what we will do, if we want to if we want to find output for a given input, like say x6, okay, so we can find out the y6, so that is regression. Okay, these are the two types of tasks in supervised machine learning. Now the second is unsupervised machine learning. Now what is this unsupervised machine learning? Unsupervised machine learning Yeah, unsupervised machine learning. Unsupervised machine learning, you are not given an output, you are only given an output. Like you will have many. Okay, yeah, unsupervised machine learning, you are not given an output. Okay, you are only given an input. Now with those input you will find some patterns. Okay, like you are given 5 points, x1, x2, x3, x4 and x5. Now 2 points are similar, other 3 points are similar, so you can group that 2 and 3 points. Okay, so you can form two types of groups, like 2 points x1, x2 and 3 points x3, x4, x5. Okay, so that is unsupervised learning. Here we are not leveling it. Okay, and second is, here we are only dealing with the input, we don't dealing with the output, so that is unsupervised learning. Now unsupervised learning, one is that grouping, that is called clustering, and there is association. What is association? Association is if x1 is there, x2 must be there, so that is called association. If one data point is there, another data point must be there, so that is association. Now third is reinforcement learning. Reinforcement learning is somewhat in between unsupervised and supervised learning. Okay, it is not supervised also, it is not unsupervised also. It is a reward policy, like your machine learning algorithm will take the input, okay, and it will produce a output. Like supervised learning, it has input output already, but here it will only have input. Now it will produce an output. Now the machine learning algorithm will work on feedback. Okay, if that output is very much deviated from the required output, it will give a penalty. Okay, so by that your machine learning algorithm will learn it and learn it and modify its algorithm. Okay, so that is reinforcement learning. It is reward penalty policy. Okay, reward, if you will do good, it is reward. If you will do bad, it is penalty. So that is reinforcement learning. Okay, now yeah, there are performance measure. I have already told you there should be some performance measure. By that only we can say your machine learning model is learning properly or not. So for that classification we will see that performance with error. Okay, similarly for regression, clustering, we are seeing it by scattering. Okay, if the scatter is more, it is less pure. If the scatter is less, it is more pure. Similarly association, yeah, support and confidence. Like confidence is main for association. Like if x1 is there, what is the confidence that x4 must be there? Okay, so that is association. Reinforcement, I have already told you, it is a penalty, it is a reward penalty type of process. So if your machine learning model will do well, we will give it reward. If it will do if it will not do well, we will compensate it by cost. So that is performance measure. Now any doubt up to this, guys?
No, sir.
Yes. Hello.
Yeah, please.
Yeah. Actually, I'm confused because the cluster Spotify clustering is schedule supervised learning, but also sometimes Spotify clustering is called unsupervised learning. So what is the difference between this?
Clustering is a unsupervised learning.
I'm talking about Spotify clustering.
Spotify clustering. I don't know Spotify. What is Spotify clustering? But clustering is a unsupervised learning, because in clustering you don't have output, neither you have label for the data. So it is always unsupervised learning. Clustering. Okay, you will only have inputs like 5 points. If you will have given like 5 scattered point, you will form two groups. Okay, two groups or three groups, whatever you want. So that is clustering. Okay, we are not leveling the data. Supervised learning only happens when you are labeling the data. Like clustering, you are giving labels, like this cluster is for like banana, this cluster is for apple. So that is supervised. But until you are giving the label of the data, it is always unsupervised learning. Okay.
Okay. That means any classification of data without label is unsupervised.
Yeah, absolutely.
Okay.
Okay,
Thanks.
any doubt in these two
Sir,
slides? I am only discussing the basics. Already you must have learned that, but it is good to revise that before going into the questions. Okay.
सर जैसे सर क्लासिफिकेशन में जो उसका जो मेजर है वो एरर मेंशन कर रखा है।
हाँ
बेसिकली
बिल्कुल।
सर बेसिकली क्लासिफिकेशन में तो हम ये होता है ना, जैसे हमारे पास कुछ क्वांटिटी है
हाँ
तो हमें उसको सेग्रीगेट करना है। अब सेग्रीगेट करने के लिए कंडीशन जो हमारे पास तो ऑलरेडी है कि हम किस कंडीशन के बिहाफ पे हमें उन दोनों को अलग करना है,
हाँ
तो हम उसका एरर क्यों यूज कर रहे हैं कि एरर की वजह का हम एज ए मेजर क्यों यूज कर रहे हैं? क्योंकि एरर तो बेसिकली ये हो गया ना कि वो कितनी गलत चीज में गलत आ रही है। अब जैसे अब हमें दो क्वांटिटी को सेपरेट करना है, अब कंडीशन का हमने यूज करा, हमने सेपरेट कर दिया, अब हम उस कंडीशन की जगह हम उसके एरर को क्यों यूज कर रहे हैं सेपरेट करने के लिए?
कुछ तो परफॉर्मेंस मेजर आपको लगाना पड़ेगा ना। तो परफॉर्मेंस मेजर जैसे क्लासिफिकेशन क्या होगा, आपको एक फल की कटोरी दी गई, ओके, फ्रूट बास्केट, ओके। तो उसमें आपको इनपुट दिया गया, आउटपुट दिया गया। लाइक इनपुट दिया गया, जो जो लाल होंगे वो एप्पल होंगे, जो जो पीले होंगे वो बनाना होंगे, ओके। तो प्रॉपर लेवलिंग होगी। अब आपको आपका मशीन लर्निंग मॉडल बन गया, ओके। अब आपको उठाना है, अब आपने उठाने की जगह बनाना आपको उठाना है, ओके। बट बनाना आपका मॉडल गलत है, ओके। और आप येलो जो होना था वो बनाना होना था, बट आपने रेड उठाया, तो एरर हुआ ना। तो बाय दैट यू कैन मेजर द परफॉर्मेंस ऑफ योर मॉडल।
सर मतलब बेसिकली ये हो गया कि मेजर करने का तरीका कि वो कितनी चीजें सही कर रहा है।
या एब्सोल्युटली।
बस यहाँ पे मतलब जैसा क्लासिफिकेशन के लिए कंडीशन की जगह हमने यहाँ पे एरर शो कर दिया कि वो कितना सही कर रहा है।
हाँ बिल्कुल बिल्कुल।
ओके सर। और सर सुपर एक चीज़ ये चीज़ है सुपरवाइज लर्निंग में, जैसे हमारे पास ऑलरेडी एक इनपुट होता है कि आउटपुट का भी हमें मतलब जैसे कि आउटपुट हमें पता होता है कि ये हमारे पास ये प्रेफर्ड आउटपुट होना चाहिए, तो हम उस बिहाफ पे हमारा एक इनपुट इनपुट जनरेट होता है, वो चीज़ होती है। अगर हम सुपरवाइज और अनसुपरवाइज को कंपेयर करें तो
हाँ बिल्कुल, लेबल होता है इसमें। सुपरवाइज में ऑलवेज लेबल होता है,
कि हमारा
अनसुपरवाइज
आउटपुट क्या
में,
आने वाला है।
हाँ अनसुपरवाइज में लेबल नहीं होता। जैसे क्लस्टरिंग ही कर रहे हो, जैसे क्लासिफिकेशन और क्लस्टरिंग आपको सिमिलर लग रहा होगा, बट क्लस्टरिंग में
हाँ
क्या
जी सर।
होगा कि लेबल नहीं होगा। या Raghupati, okay. Actually, who is asking question in Hindi. So yeah, so he is asking that why we are measuring error as a performance measure for this classification task. Okay, so that is what I am answering. Okay, who had asked this? Raghupati, right? Yeah, Raghupati. Is it clear, Raghupati? Hello.
Sir, no, sir.
Okay, so his question was classification, why we are measuring error as a performance measure. Okay, so that is my answer. My answer is that classification, like you are making a model to classify fruits from a fruit basket. So classification always for making a supervised learning model, you should have first input as well as output. Okay, so let's say input is your color. Okay, color, uh, if the color is yellow, it will be banana. If the color is red, it will be apple. Okay, so we are making a model. Now after making a model, we are told to predict the output from a unknown input. Okay, now if our model is classifying yellow as apple, so it is a kind of error, right? So that is a performance measure of the model. Okay, how much error it is doing. Like if we are classifying it for 50 fruits, if it is measuring for 40, it is given no error, but 10 it is giving error. So by that we are measuring the performance of the model. Okay.
Okay, sir, understood.
Okay, so any more doubt from this slide? Very basic slide, I think.
Sir, what is the difference between classification and clustering?
Yeah, classification and clustering. Classification, you must have a label for the data. Okay, clustering, you don't have any label. That is the major difference. Like if you are segregating a fruit, different type of fruit in a fruit basket, classification we will have label, like this is banana, this is apple. Okay, but unsupervised learning, clustering, we will not label it. We will say, yeah, this looks same, so this is a group, this looks same, so this is another group, but we are not giving label to the data. So that is clustering. Okay.
Thank you, sir.
Okay, okay, so let me move forward.
Sir, one more thing.
Yeah, yeah.
Uh, Reinforcement learning is a combination of supervised and unsupervised.
It is neither supervised nor unsupervised. That is a correct statement. Okay. Okay.
But clustering, association, or classification, regression, nothing comes in this reinforced learning.
Classification, no, no, no.
No.
Okay, so let me move
So,
forward. Now we will discuss something about supervised learning. Okay, supervised learning, first is classification. So classification, I have already told you. Okay, some people are still joining. Yeah, so supervised learning, what is the major requirement of supervised learning is we require labeled training data. Okay, labeled data we must have. If we don't have label, we cannot go with our supervised learning. Okay, so this is the use case. Okay, this you can see, this is income, this is age. The red points are the person who will buy computer. The blue points are the person, sorry, the red points are the person who will not buy computer. Blue points are the person who will buy computer. Okay, now we have to do a classification task. So how we will fit our model, so that we will see. Now for fitting a model or making a classifier is basically a machine learning model. Okay, so how we will fit our data. Okay, so we have to find some relationship between input as well as output, so that once we have unknown input data, we can predict our output. Okay, so that is our target. Now how we can classify those. So first step, how the basic, how we can classify by putting a straight line in between. Okay, so here we are using only one axis, like x equals to, like income, x equals to okay, again people are joining. Okay, so like x equals to, let this be the yeah, this is the income axis. Okay, so let x equals to like 50,000. Okay, so before 50,000, who are earning below 50,000, they will not buy computer. People who are earning above 50,000, they will buy computer. So that is our model. So this is one type of our classifier. Okay, so here the problem is, what happens is, it is not a good classifier. Why it is not a good classifier? Because you can see, what we are doing is, we are telling before 50,000 people will not buy computer, but above 50,000 people will buy computer. But here we can see that above 50,000 also 3 people are not buying computer. So this is a classifier, but it is not fully able to classify our data. Okay, so this is the first classifier. Next, how we can classify? We can put a slanted line, that is, we can make use of both x and y. Okay, this is a equation of a line, y equals to mx plus c. Okay, y equals to mx plus c means we have two parameters. Here we have only x equals to something. Okay, so we have only one parameter. Here we have two parameters. We are using x as well as we are using y also. Okay, slanted line. Now whenever we are going for this slanted line with slope as well as intercept, what happens is, here our error minimizes. Okay, you can see here error is more, like 3 data points we are classifying as person will buy computer, but they are not buying computer. Okay, but here only one, here what is happening is, one person we are telling one person we are telling he will buy computer, but he is not buying computer. Similarly, one person we are telling he will not buy computer, but he is buying computer. So here we have error of 2 data points, but here we have error of 1, 2, 3 as well as 4 data points. Okay, so we are somehow reducing the error. Now how to reduce the error further? If we can go with a non-linear model. Okay, this is a linear model, this is a straight line, this is again a straight line, but this third one is a non-linear model. Now whenever we are putting a non-linear model, the error further reduces. Here there is an error of 2 data points, this is an error and this is an error. Okay, but here there is an error of how many data points? Only 1 data point. Okay, and here we have error of 4 data point, this is error, this is error, this is error, and this also is a error. So 4, 4 to 2 and 2 to 1. So we are minimizing the error. Now how we can completely reduce the error? If we are fitting this curve. Here you can
Sir,
yeah,
sir,
hello,
one
hello.
question. As much as if we try to minimize the error,
Yes, yes.
the function will become more and
Com-
more complex.
yes, complex and parameter will increase. Okay, here
Parameter
we
will
have,
increase complex and function will become more complex
yes,
because
yes. Yes, you are right, very right. Whenever we are going for more complicated model, we are increasing the parameters also. Okay,
so how come we can assume that our machine learning model is absolutely perfect?
see, we don't want a perfect model, okay? In the lecture, in the ahead lecture, I will discuss that we don't want a perfect model, okay? This model is absolutely perfect for us, because in deployment, whenever we are deploying a thing, we want the simplest model. Yeah,
Yeah, but
here we
having
have
some error.
error more, but what will happen is, it is this is this is not overfitting, this is overfitted, okay? Overfitted, what will happen is, if there's something, it is according to your input data only, means it is according to your training data only, but when you will give it a test data, this model will not perform well, but this model will perform better, okay? So you have to have a trade off between your accuracy and deployment. So
Yeah.
yeah, so real models, we are going for we are more going for deployment tasks, we are less focusing about accuracy, okay?
Means
So four data points.
trade-off
Yeah, the
trade-off exists in terms of accuracy
accuracy.
and more complexity.
Yeah, yeah, absolutely. Okay, so this
Okay,
is the thing.
got it, got it. Thank you.
Okay, so anyone, any doubt in this slide,
So
how we
sir,
are fitting
basically,
yeah, yeah,
when we are selecting a classifier, like
yeah, yeah,
we have to see which model is giving us best results
yeah,
based based depending upon the complexity. So sir,
yes, yes,
like you are saying, first one is the best, but it is giving us an error of 4.
yeah,
But
yeah,
if we go to the third option,
yeah,
it is
yeah,
giving an error of 1. So
yeah,
sir,
yeah.
according to you, sir, why, is it, how the first one is the best option?
First one is
Because if
it
we compare,
cannot yeah,
it
it
is a bit
cannot be,
complex, sir.
yeah, it cannot be best option for you, but for deployment, here the parameter is only one, x equals to something, that is your only model equation, but here it is a quadratic equation. Quadratic means two things you will consider, okay? Ax square plus bx plus c, that is the equation here, but here only you have x equals to something, so this is your simplest model. Okay, so for deployment purpose, you can go with the first model, that will be more better. But if you want accuracy, you don't want to deploy the model, you just want to be accurate. Deployment, I am telling about real deployment, whenever you are deploying your model in some edge device, okay? So for that, first model is your best model. But if you are only doing on your machine, okay, so for that, the third model or the second model will be your best. Fourth model is not best, because it is overfitted, there is no relation, we are just fitting our training data, that is what we are doing, so that is not good, okay?
So sir, so basically the classifier best will be depending upon the device and what is the cost and what
Yeah,
will be the most beneficial.
what is the task first, okay? How much accuracy you want to go, and with accuracy, if you want to compromise your deployment ability or not, so that is the thing.
Okay, sir.
Okay, so this is about classification, okay? Now we will yeah, this is the process basically. Yeah, this is, yeah, okay, so we are this is the training data, okay? Here there are training data, right? x1 y1 x2 y2 x3 y3, so that is only written. So we are picking 2 point x1 y1, and we are telling it is it does not buy a computer. x2 y2 we are picking, and we are telling it will buy a computer. Now for machine learning model, what you will do, you will segregate your data into two type of sets, okay? Two or three set. Basically for machine learning, you can go with two set only. One is training set, the data by which you are training the model, and you are conserving some data for testing, okay? So training the data, for training, all this you are seeing, we have utilized this only for training. Now we will have some data for testing the model, okay? Testing means we know what is the means we know what is xn, we know what is yn, but we will test our data, and we will predict yn dash, okay? And we will compare the error, okay? If the error is less, we will validate the model. If the error is more, we will look into a more complex model. So this is simple thing. And also, yeah, classification task can also be regarded as a regression task. How it can be think as a regression task, if we will convert our output into a value. Like, if let's say we will say the person does not buy a computer, we will give it -1. The person who will buy a computer, we will give it +1. So that will become your classification, will become your regression task. Okay, because now we are dealing with the values. Now we are not dealing with some kind of label. Okay, some kind of wordy label. So a classification task can be considered like your regression task. So that is only thing. Second thing, yeah, second thing, whenever you are going with the data and it has many unsimilarity, like the here you can see age will be between 0 to 100, let's say, but income will be between 0 to 1 lakh. So there is there is there is very much variation. Okay, like age is only going from 0 to 100, but your income will go from 0 to say 1 lakh. Okay, so there is a much more variation. So to deal with this variation, what we will do, we will normalize our data. How we can normalize our data? We can normalize our data by taking one data and divided by maximum value data. Your x1 will be x1, let's say it is x1 and this is y1. Okay, this is x1 and this is y1, but x max, let's say x max is your 2 lakh. Okay, so 30,000 divided by 2 lakh, and that will be 0.15. Similarly, age, let's say age maximum age is 100, so 25 divided by 100 will be 0.25. So by doing this, what we are doing is we are decreasing the irregularity between two sets of different data. Okay, so that is what we are doing. So that is known as normalization. Okay, your value divided by maximum value. So we are normalizing the thing. So that is another thing, and rest of nothing important in this slide. Now we will go for regression task. Very similar, classification and regression. Regression, we have numerical values. Okay, classification, we have word values, like whether it will not buy a computer or it will buy a computer. But regression, we have we only have output as numbers. Okay, so this is regression task. So there are two axes, temperature axis and time of day axis, and these are the points. Okay, this cross are your points. Like this is your x1 y1, x2 y2, x3 y3, and similar. Like, now how we will fit a regression model. So we can fit a regression model. We can just fit a model by a straight line. This is the again a simplest model, but here you can see the error is more. Okay, error, how you can calculate the error? You can calculate the error by predicted value minus the actual value. Okay, so if we will take this model, let's say, and we will see at x1 y1 is your actual point, but your predicted point is x1 y1 dash. So you can say y1 dash minus y1 is your error. Okay, and you will sum the error and find the total error. So that is one type of performance measure. Now how we can reduce the error? If we can go from straight line model to a quadratic model. So this is a quadratic model. Now in this quadratic model, the error is less. Okay, if you can add those error, you will see the error is less here. Okay, the error is more here. You can see error is more here. Here you can focus at this point. Okay, this point, all this point, this quadratic equation, the total error will be less than your straight line equation. Now third is again a overfit model. According to our training data, we are totally fitting the model. So this is good for accuracy, but again when you will deploy this model will not work, because we are totally fitting our training data. Okay, so let's say here we will predict our new input. So this model will not give you the correct output. So these are the again three types of regression model. So the simplest is the model, error will be slightly more but good for deployment. The more complex is the model, it is not good for deployment. And if it is overfit, means if it completely fitting your training data, that will be good for nothing. Okay, not good for accuracy. It will show good accuracy, but it will definitely not good for deployment. Okay, so this is the thing.
So I have one question.
Yeah.
Overfit model is it used, or it's only
No,
for the?
no, overfit model we will not use. It is only for explaining you. We will never use a overfit model.
Sorry, it is only for.
Only for explaining you what is a
Okay,
overfit
okay,
model. We will not
okay,
take this. Okay, we can go to second model only, or we can
okay.
go for first. Okay, but never take the third model, because third model we are completely fitting the training data. So whenever we are predicting on a
New value,
new
new input.
new input
Yes,
value, it will
yes.
not give you the correct output.
Okay,
Okay,
right.
this is the
Thanks.
thing. Now go to the second. Yeah, any more doubt in this slide? Okay, no problem. Now we will go to, yeah, linear regression. The first thing is linear regression. You can see a linear regression model. Now I have already told you how to calculate the error. What we will do, we have let's say take this point. Okay, x1 y and this point is x1 y1. This point is x1. This point is x1 y1. But your predicted value is x1 y1 dash. So there is an error. What is the error? Error will be y1 dash minus y1. So this is an error. Similarly, there will be an error in the second point, that is y2 dash minus y1. Now there will be again an error y3 dash minus y1. So we will how we will find out the error? We will find sum of squared error. Now why there is a need for squaring the error? That is a question. So what happens here will be that there will be a difference in sign. Like this is your, here the predicted value is more than the actual value. So let's say this is a positive, but here you can see the predicted value is less than the actual value. So here the sign will be negative. But here this is also error. If we are if we are just adding it, like delta y1 plus delta y2 plus delta y3, what will happen is this error and this error will cancel out. So that we do not want, because this is also error. So that is why we are squaring the error, and we are taking the sum of all the squared error. That means delta y1 square delta y1 square plus delta y2 square plus delta y3 square, similarly like that. So that is the only motivation for squaring the error. Okay, so any question in this? Another thing we can do is absolute error. Okay, sum of absolute error. So instead of square we can absolute this, like y1 will be also positive, delta y1 will be also positive, this delta y3 will also be positive. That you can do. Okay, so any
So
doubt in this?
this model we can also called as a magnitude of the
Yeah,
difference.
magnitude of the difference, that is called sum of absolute error. Okay,
Okay, okay.
that you can call. That means you will mod every value, every error. So by that your two different types of two different signs of error will not get cancelled with each other. Okay, it will only add up. So that you can do, or you can square the error. These two are the methods. Okay. Okay, so now go to unsupervised learning. Unsupervised learning, here you can see the difference. Here we have unlabeled data. Previously we have labeled data like income, age, and person who will buy computer, not buy computer. But here we only have input, like we only have data. We don't know what type of data is this, etc. Okay, so we have unlabeled data. Now we will do the clustering. Okay, cluster. we can do this. We can let's say n equals to 4. We want to make 4 cluster. So we will see how we will see according to how this points are scattered. Okay, so we are seeing these points are close to each other, so we are making one cluster here. Let's say we are seeing that these values are close to each other. We are making one cluster here, and similarly we are making 2 cluster here. So that is clustering. Here the difference is we are not labeling the data. We don't know what type of cluster it is. We have given that make 4 cluster. We are making 4 cluster according to the similarity of the data points. Means the data points which are close, we are making one cluster. Similarly the data points which are close another end, we are making another cluster. So that is the difference between supervised learning and unsupervised learning. Okay, is it clear? This is very important. Is it clear? Like you can see, you can probably compare with this slide. Here you see there are label like age, income, also person who will buy computer and not buy computer. Okay, so proper labeling is there, but here there is no labeling. We are only given just data, and we are told to cluster it, means form groups. So we have made 4 groups. Okay, yeah. Someone was asking something, please.
Can you repeat repeat about unsupervised learning?
Supervised learning.
Unsupervised.
Yeah, unsupervised learning means the data we are supplied, it is not labeled. Okay, it is not labeled. That is the only difference. Like previously the data was labeled, right? There were red points, there were blue points. Red points, person who will not buy computer. Blue points, person who will buy computer. Okay, but here we don't know any label, we are just given data. Okay, this is the basic difference.
So any applications or examples of unsupervised learning?
Yeah, unsupervised learning can be used for segmentation of an image. Okay, like image, you can see there is a sky. Okay, below there will be a building. So sky, we are assuming that this one is a cluster, this one is a cluster. That type of clustering you can do. Okay, image segmentation, there is a use of clustering. Other examples you can find in your lectures. Okay, there we will get more examples. Okay, so let me move further. Okay, now, yeah, there is another thing, rule mining and mining transaction. So similar things, like I have already told you, detail you will be learning in the 8 classes, more details, but here I am telling in short. Rule mining, associate rule mining, that means if one data point is there, another will be there. Like if one data point is occurring frequently, the another will also occur frequently. So that is, we are associating the things. One is clustering, we are only forming group. Second is association, that means we are telling if one data point is occurring, the another will occur. So that is association. Okay, this thing you will learn in more detail in the ahead classes, so I am not telling in detail here. So you can only see the concept. Clustering, we are grouping. In association, rule mining, or whatever mining is there, operation, we are relating the data. If one point will occur, and a point will also occur, something like that. Okay, so this is the thing. Now we will go to reinforced learning. Reinforced learning is neither supervised nor unsupervised. Okay, like learning a cycle. Whenever you are learning a cycle, you have some input. Okay, but you don't have the output. Okay, you have some input, you know that I have to ride a cycle, I have to try. Okay, that input only you have, but you don't have accurate output, that if you will ride cycle, how it will you will fall or not. So how it is reinforced learning? Whenever you are riding a cycle, okay, learning to ride a cycle, if you will fall, you will not do the same process again. But if you will run your cycle smoothly, you will follow the same process again. So this is reward penalty. If you are falling, you are giving penalty to you, like I will not do this again. But if you are able to successfully ride it the cycle, you are giving reward to it. Okay, like I will ride in this way so that I will not fall. Okay, so this is this is reinforcement learning, that is neither unsupervised nor supervised. It is based on the concept of reward penalty. You will if you are able to complete your task successfully, you will give a reward to it, and you will do that task more well. But if if you are applying your model and your model is failing, you will give it a harsh penalty so that your model will not do that type of task again. So that is reinforcement learning or learning to control. There is a framework: reinforcement learning, agent or machine, whatever, agent, and there is an environment. So agent will do action and it will ask the environment whether it is okay or not. If the environment is will tell it is okay, then the environment will give a reward to the agent, and the agent will follow the process like that. If your environment will tell it if your environment will tell that it is not a good process that you are running, then you will give a penalty. Okay, the agent will not repeat it. So that is the thing. Okay, reward penalty. If your machine learning model is doing fine, you will give it a good reward. If your machine learning model is not doing fine, you will give it a penalty. So by that, your machine learning model will learn step by step. So that is reinforcement learning. Okay, so yeah, so last thing is bias and variance. Okay, there are two types of error in a machine learning process. One is bias and another is variance. Okay, what is bias? Bias is one type of error that occurs due to wrong assumption about the data, assuming data is linear when in reality data follows a complex function. So that is bias, means your regular type of error, that is bias. Like you are seeing in the first process classification, some points you are not able to detect well, so we are calling it error. That error is only called bias. And what is variance? Variance is variance get introduced high sensitivity to variation in training data. If your training data has more variation, then your variance get introduced. So these are the two types of error. Now this is a chart about bias and variance. Again, for bias and variance, you need to do a trade-off. Okay, if the bias is like more, your variance will be less in real models. But if your bias is less, your variance will be more. So that is the thing. Okay, so you can see there are four type of cases, like 2 cross 2. Okay, bias low, bias high, variance low, variance high. So 2 cross 2, that means we can form four type of cases. Okay, so one is low bias, low variance. Okay, this is low bias and low variance. This is the ideal model condition, but this don't happen. Okay, second is bias is more but variance is less. You can see here properly. Variance means scattered. Okay, this is your target, this black color, you can see this is your target value, and this is your predicted value. This all are predicted value. Now bias, what is happening is more bias, what is happening is this predicted value is deviated from your actual value, or this green dots are deviated from your black dot. So that is our model is more biased, or our model is encountering more error. But thing is, the model has less variance. How we are calling it less variance? Our predicted value are very close to each other, like these green dots are very close to each other. So that means our model has more bias but less variance. Okay, now now second thing is now second case is this case. Okay, this case is more bias, more variance. Again, this model we will not accept. Why? We will take a model that will have more bias, more variance. So this will not study at all. This we will study. That means our bias is less. You can see this training data are very close to the black point, or green or predicted values are very close to the black point. That means our model has that means our model has less bias, but our model has more variance, because the data points are very much scattered, or predicted value are very much scattered. That means your model has less bias but more variance. Okay, so four cases. One is less bias, less variance. This is the most ideal case, but again, in reality, ideal things don't happen. Okay. Second is our model has more bias but less variance. Okay, this is second case. Okay, second case. And this is third case. That means our model has less our model has less bias but more variance. Okay, that means our predicted values are scattered but bias is less. So that is the third case. And fourth case, that is more bias, more variance. So again, this we will not accept. So our real model will be between second and third. First is the ideal case, but ideal don't happen. Fourth is the more bias, more model, more bias, more variance. So we will eliminate it. So our real model will be between 2 and 3. Okay. Now you can read this. If we can say high bias and low variance, means if we will take this second case, a model with high bias and low variance is said to be underfitting model. Okay, underfitting. Now underfitting means error is more, so our model is underfitting, like a straight line model. It is underfitting with our training data. Okay, so that is more will be the bias but variance will be less. Now third model, that is high variance low bias. High variance low bias means our model is overfitting, not overfitting exactly, but prone to overfitting. That means it is properly taking the training data, but when it is predicted, its variance is more, it is scattered. Okay, so that is the third case. High bias, high variance, we will not accept. Low bias, low variance, it is the ideal case. So again, this will not happen. Now again, we have to do a trade-off between our bias and variance. Okay. Now more complex is the model, like we have seen in a quadratic model. Okay, the quadratic model, what we have seen, our bias is less, but when the bias is less, our variance will be more. Okay, now again we can tell this in another way. If we want less variance, then our bias will be more. Okay, so this is the, again we have to do a trade-off. So like a straight line model, if we can say the simplest model, bias will be more but variance will be less. But like we are moving towards a more complex model like quadratic, etc. So in that, our our bias will be less but variance will be more. So again we have to do a trade-off. So this is the theory behind this slide. Any doubt in this slide? This is the last slide, then we will enter in our question answer. Okay.
सर बेसिकली सर डिफरेंस बता सकते हो बायस और वेरिएंस में क्या होगा?
Again please repeat.
Sir, can you tell me the basic difference between bias and variance? Like they both are
Bias means,
showing.
bias means error. Okay, simple error is bias. Variance means in your predicted value how it is scattered. If it is less scattered, less variance. If it is more scattered, more variance. Okay.
Hello.
Yes.
It means variance is not a error, right? Because it is the variation of the training data, right?
Actually, whenever you are doing any science experiment, you must have heard a term called precision. Okay, there are
Right.
two terms, precision and accuracy. So whenever we are doing a science experiment, we want less variance also, or less precision, so, or more precision also. That means we want our predicted value. If we are giving our input x4 x4 x4, then the y4 dash, y4 double dash, y4 triple dash, that should be very close. That we want also.
Yes, yes. Double precision or this
Yeah.
type का
Now
right.
again there is a trade-off between precision and accuracy. Okay, so this is the thing. You have to trade off.
Right, right, right.
Yeah.
Thank you, sir.
Okay, so let me enter into the question answer session. So now I will discuss with you 10 questions that will be very similar to your assignment. So whenever you will do the assignment number 1, you will not feel alienated. Okay, so that is my purpose of doing the question answer session. Now in question answer session, I will be giving you the question. I will tell you to guess the answer, and everyone please write your answer in the chat box. Okay, and then we will discuss whether your answers are right or wrong. Okay, so one by one question we will discuss, and I will first ask you the answer, and then I will discuss with you the answers. Okay, is it clear? Okay, so these are the topics from which are week 1 assignments. So this is the question number 1. Which of the following is our unsupervised learning problem? Okay, grouping documents into different category based on their topics. First option A. B is forecasting the hourly temperature in a city based on historical temperature pattern. C is identifying close knit communities of people in a social network. D is training an autonomous agent to drive a vehicle. E is identifying different species of animal from the image. Yeah, A, C, D, E. Any other guesses? A, C, D, E. Okay. Are you sure D? Yeah, someone is telling A. Okay, nice. Okay, so let's see the answer. So A and C is your correct answer. Okay, so identifying different species of animals from image. Why it is not so? Because see, identifying different species of animal from images means we are also leveling the data here. Okay, so that is why we are not taking E. But here we are talking about topics. Now topics can be vast. Okay, but if it is not labeled, so that is why we are telling this as unsupervised learning. Okay, A. And similarly, C, close knit communities of people in a social network. Again, we are not labeling it. Like if we have labeled this like similar type of people, those who are doing job, those who are in school, those who are in this, those who are in that. If we are doing that, then C will be your supervised learning. But as we are not telling as we are not telling what type of people are there, that means as we are not labeling our data, so C is also a correct option. Yeah, E you can say. E is a confusing thing. Okay, if the animal name is also labeled, then it is a supervised learning. But if animal label name is not labeled, then it is a unsupervised learning. But here in the question, I think the animal name is not labeled according to the question maker. So that is why E is a supervised learning they have considered. But if you can say A, C, and E, then the A, C, and E can also be treated as correct answer. Okay. Why not D? Training an autonomous agent to drive a vehicle. Training an autonomous agent to drive a vehicle is your reinforcement learning. Okay, like like learning to cycle. So this that is your reinforcement learning. Okay, C is correct. Yeah, C is correct. Someone is telling D. Yeah, D is not correct. A and C is correct. A, C, and E can be considered correct answer. Doesn't close knit community itself is a label? No, close knit community itself cannot be a label, right? Until you are mentioning how close knit means. Yeah, if you are telling that we are labeling it like someone is studying in school, someone is studying in college, someone is doing job, so that in that case it is properly labeled. But simple close knit community, it cannot be labeled. Can you please let us know reinforcement learning again? Yeah, reinforcement learning is your D problem. Like similar case what I have discussed in learning a cycle. Okay, similar training a autonomous agent to drive a vehicle means you are training an autonomous agent to drive a vehicle. It will again learn by experience or learn to control. Like if it will if Like if it will drive it smoothly, it will give it a good reward and it will follow the path. But if it will collide to something, it will give it a penalty. Okay, so by that D is a reinforcement learning problem, not a unsupervised learning problem. Okay, A, C, and E can be considered right, but here A and C is only considered according to the question maker, because E, I think he has species of animal, right? So I think this he is telling it is labeled. But again, there can be a confusion in in E option, but A and C will be your always correct answer. Okay. Any doubt in this? Anyone? Any doubt in this question?
So there is a disturbance from.
Yeah, document. Yeah, Suma, please unmute yourself. Yeah, mute. Yeah, I have muted it. Now it is okay, right? Now there is no disturbance, right?
Yes, sir.
Yes.
Carry on.
No.
Okay.
Yeah.
Yeah, any doubt in this question?
No, sir.
Okay. I think simple question, and some of you were asking the example, so you are getting two
Sir,
different examples.
about the E option, sir.
Yeah.
E option. Why it
Yes.
is not
Hello.
unsupervised? Why it is not unsupervised? E
Yeah,
option.
it can be unsupervised. According to the question maker, they have given it a supervised learning, because they have considered species of animal as labeled like species of animal, what tiger, lion, etc., etc. But even if you will tell it as unsupervised learning, this will also be considered right, because you don't know whether the training data is labeled or not. So E can be correct, cannot be correct. Okay, but A and C is correct. Okay.
Okay, sir.
Sir, is this
Excuse
session
me, sir.
recorded?
Regarding option A, grouping into different categories based on the topics.
Yeah.
I think based on the topics is labeled
No. Based on the topics is not labeled. Based on the
because topics are mentioned here. Because the topics thing is mentioned here.
yeah, topics thing is mentioned here, but we don't know what type of topics, right? Here close knit community is also mentioned, but we don't know what type of close knit community, right? Until it is properly labeled, it should not be. That is why that is why there is a confusion. E can be considered as a correct answer. Okay, until you are labeling it like topic, like different type, history, geography, etc., etc., so that then it is okay. But until you are giving it a proper label, it is unsupervised. Okay.
So, sir, in exam, do we have to mention
Is
E
this
or not?
session recorded?
Yeah, E you can mention, according to me you can mention. Okay, because again here it is not given, so E you can mention. Okay. Okay, so let me move to the second question. Which of the following statement about reinforcement learning is that true? While learning a policy, the goal is to maximize the long-term reward. Option A. Option B. During training, the agent is explicitly provided the most optimal action to be taken in each case. Option C. The state of environment changes based on the action taken by the agent. D. Reinforcement learning is used for building agent to play chess. E is reinforcement learning is used for predicting the price of the apartments from their features. A, B, and C. Okay, B and C. A, B, C, D. Okay, C. Okay. Yeah, C is correct. Yeah, everyone is telling C. C is correct. Yeah, A is also correct. B. B, someone is telling, someone is not telling. Okay. So let's see the answer. So the right answer is right answer A to D is all A, B. Okay, refer to lecture RL. Option E is supervised learning. Yeah, E is supervised learning. A, B, during training, the agent is explicitly provide most optimal action to be taken at each case. So this is false. the agent is not provided most optimal action. Okay, he is only learning. Okay, if the output comes good, he is giving him reward and following the process. If the outcome comes false, he is giving him a penalty. Okay, so B is a incorrect option. Okay, E is already incorrect option, because here you can see it is predicting prices of the apartment from their features. So this is kind of supervised learning. Okay, regression problem. A is correct. While learning a policy, the goal is to maximize long-term rewards. So this is very correct. Yeah, B is not correct. Why it is not correct, I have told you, because the agent is not told first to take the most optimal action. Okay, he is only learning by experience. C is correct. The state of environment, I have already shown you this chart, that in reinforcement learning there is a communication between agent and environment. Okay, so by action of the agent, the environment changes. Okay, so C is also sorry yeah, C is also correct. And D is RL is used for building agents to play chess. That is an example. Okay, that is also correct. Like reinforcement learning can be used for learning how to ride a cycle. Okay, so by that concept, this is also D is also correct. So your correct option is A, C and D. Okay, B is not correct. You all understood why B is not correct?
Sir, I want to ask that, like in B, the agent takes the, it is based on like reward and penalty
Yeah,
option.
yeah.
So, it will, so sir, the agent will take the best option to get the reward. So,
No, the agent will take the action, and if the error will be more, he will give a penalty or reward. But in the first case, the agent will not take the most optimal action, right? If you are starting the
sir,
process, the agent will not take the most optimal action. The agent will just take the action, and if he succeeded, he will give him a reward. If he is not succeeding, he will give him a penalty. Okay.
So here most optimal action. What is the explain?
Optimal action means if he is learning the cycle at the first go, but that is not right? He will learn it by reward and penalty. He will learn it. He don't know what is the most optimal action in the first case. He will
Okay,
only learn by experience.
okay.
Okay, so I think it is clear. Let's move to the next question. Which of the following is our classification task? Okay, multiple option can be correct. Predicting whether an email is spam or not spam. B. Predicting the number of COVID cases over a given period of time. C. Predicting the score of a cricket team. D. Identifying the language of a text document. Yeah, A and D. Yeah, A and D. Yeah, A and B. No, A and B is not C. Someone is telling C. No, A and D, A and D, A and D. Yeah, this is a very simple question. I hope many of you have predicted it correct. The right option is A and D, because B and C is your regression task. Okay, B is your regression task. That means it is dealing with numbers. Okay, so this is your regression task. This is again your regression task. But A, predicting whether email is spam or not spam. Again, we are leveling the data. So it is a supervised classification task. D. Identifying the language of a text document. Again, there can be confusion. It is a regression task, or it is a classification task or a unsupervised learning task, because if the language is specified, then it is a classification task. If the language is not specified, it is a unsupervised task. But here they have considered it as unsupervised. Here they have considered it as classification task. So A and D is your correct option. Okay.
Sir, could you explain what is regression task?
Regression, you have seen this example. Temperature. Yeah, you can see this time of the day and temperature. Okay, so these are your input data or training data. rather you can tell it as training data. Okay, these are your training data. So we will make a model. Okay, and now we will predict from this model. Let's say this is your machine learning model. Now if we are predicting it for this is your, let's say this is daytime. Okay, this is, let's say 9 p.m, this is 10 p.m, this is 11 p.m, this is, let's say 1 p.m, this is your night. Let's say this is 7 p.m, 8 p.m, 9 p.m, 10 p.m. Okay, now you are required to find what is the temperature at 12 p.m or 1 o'clock. Okay, so you can 1 o'clock in the night, so you can find out what is the temperature at 1 o'clock in the night. Okay, so this will be your temperature. Okay, so this is a regression task. Is it clear?
Right.
Okay, sir.
Oh,
Right.
But this
But regression could
will
act
not
as a
come under
classifier, right?
this will not come under, please repeat.
classification.
No, this is not classification, this is regression. This is a supervised machine learning, but this is not classification. This is a regression task. Why it is a regression task? Because here we are dealing with a number. Okay, the predicting value is your number. If the predicting value is your label, word label, like if it is hot cold, like how it can be how this can be called as a classification task if it is only if these points are giving you only wordly level, like the temperature is hot cold, hot cold, hot cold, like that. So that is a classification task. Okay, regression task, if it is giving you the proper temperature. Okay, so that is a regression task. Yeah, regression continuous output. Yeah, very right. Regression is a continuous output. Classification is a not a continuous output. So by this also you can classify. Okay.
Sir, labeling the data means color difference, red, blue, or buying a computers like that only, no, sir.
Labeling the data means accurate, when you are giving accurate input as well as output, so that is labeled data. like uh, like you can like you, classification, it is very clear, it is by computer or not by computer, right? So it is very clear classification. Here why we are calling it a labeled data, because we are given the axis, time of the day as well as temperature. If we are only given this red data point and we are not giving the axis, so that is a unlabeled data. We don't know what type of data is it, we have data. But here properly labeled are given that this is a temperature data for particular time of the day. Okay, regression could act as a classifier, isn't? No, classifier is different. Classifier can act as regressor, but regressor cannot act as classifier. Okay, classifier, how we can how we can make regressor from classifier. The output that we are getting, if we are giving a numerical value, like by a computer 0, not by a computer, sorry, by a computer 1, not by a computer 0. So by that we can convert our classifier into a regression model, but we cannot convert a regression model into a classification model. Okay.
So how to identify reinforcement actually, unsupervised and reinforcement, how to identify it?
Unsupervised, it is very clear. Unsupervised, we don't have that labeled data, we have unlabeled data. You can see here we have only data, we don't have any type of label, we don't know what axes are there, we don't know what these points are. So unlabeled data means unsupervised learning. Okay, now reinforcement learning. Reinforcement is neither supervised nor unsupervised. Okay, why it is not supervised? Because we don't know that we don't know exactly that if we are giving our input x1, it should be x2, y1 should be your output. So input output is not clear there also. Okay, we know that we are using a reward penalty system, means we are giving a x1 value, we are giving a output. Now this y1, if you will fall by your cycle by that y1, we are giving it as a penalty. If you will ride your cycle comfortably, we are giving it a reward. So that is reinforcement learning. Okay, supervised and unsupervised must be very clear, at least. Hello, am I
Yes,
audible?
sir. Clear, sir.
Yeah.
Clear, yes, sir.
Yes, sir. Yes, sir.
Okay. Now, let us move. Now, fourth question, which of the following is a regression task? A. Predicting whether or not a customer will repay a loan based on their credit history. B. Forecasting the amount of rainfall in a given place. C. Identifying the type of crops from the aerial image. D. Predicting the future price of the stock. Yeah,
B and D.
B, D,
B and D.
B, D. Yeah, promote miss D, I think. Yeah, BD. Yeah, again a very simple question. Yeah, see, A option, predicting whether our customer will repay a loan or not. So this is classification, whether the person will repay loan or not repay loan. So this is classification. This is not regression. This is only classification. B. Forecasting the amount of rainfall in a given place. This we have seen that temperature and time of day curve. So similarly, we can make a curve for number of days and amount of rainfall. So by that we can make a regression model. See, identifying the type of crop from the aerial image of farm. Again, this is a classification task. That means what type of crop, whether it is rice or paddy or wheat, etc. So C is your classification task. D, predicting the future price of the stock. It is dealing with numbers, so D is your regression task. So B and D is your correct answer. So I hope it is well understood to everybody. So let's, yeah, any doubt?
Sir, A option in credit history is numerical values only, na, sir. But why it is not come under regression task?
Yeah, you see the task. The task is whether the customer will repay loan or not repay loan. Okay, that is the task. Okay, so there are two classes, whether the person will repay loan or not repay loan. Similar to that example that we have discussed, whether a person will buy computer or not buy computer. Okay, so that is a classification task, right? You can classify it. The person will buy computer, not buy computer. So that is a classification task. But here you can see forecasting the amount of rainfall. That you can say, you cannot say, yeah, this task can be classification task when you are giving a word level to it. Okay, like whether you are predicting whether it will be a high rainfall or low rainfall, then it is a classification task. But here you are forecasting amount of rainfall. That means you are dealing with the values like 50 millimeter, 40 millimeter, 10 millimeter. So here it is a regression task. Okay.
Okay, sir.
Now question number 5. Consider the
Sir,
following. Yeah, please.
sir,
Yes,
sir,
please.
basically, regression means when we are dealing with values or numeric values, this means regression.
Please repeat.
Sir, when we work with numerical values, this
Yes,
means
yes,
is regression learning. That means we are doing regression learning.
yes,
Is
yes.
that what it means?
Yes,
Okay,
whenever the
thank you.
output is coming in terms of your numerical values, output, everywhere you are dealing with numbers. Okay, but the output is coming in terms of your numerical value, that is regression. But in classification, the output is coming in terms of a word level. Okay, like will buy a computer, not buy a computer, this is word level. Okay, but here you are forecasting the amount of rainfall, etc. So there the amount of rainfall cannot be high low. Amount of rainfall will be 40 millimeter, 10 millimeter, like that. So that is a regression task. This can be termed as a classification task if your amount of rainfall is considered high rainfall or low rainfall or medium rainfall. So there you are classifying it. The output is coming in terms of wordly level, but here the output is coming in terms of numerical value. So that is why it is a regression task. Okay. Okay, I think it is clear. Now this is a numerical question. Consider the following data set. Okay, okay, why it is not come. Okay, this is x1. Okay, and this is x2. Okay, this is x1, x2. Okay, so here consider the following data set. This is the data set, and y is your output. Okay, x1, x2 is your input, y is your output. Okay, fit a linear regression model. This is your model, y equals to beta naught plus beta 1 x1 plus beta 2 x2 using mean squared error loss. Okay, using the this model, predict value of y at the point x1 x2 uh, 0.5 and minus 1. So how you will do this? Okay, so this is a numerical question, so this you will do by this equation. Okay, beta or the constants will be xt transpose of x matrix, x matrix into x matrix, and we will multiply this and we will take the inverse, and then again we will multiply it with the transpose of x matrix, and then we will multiply it by y matrix. Now what is x matrix? X matrix is this. Okay, this whole things is your x matrix. That means this is a 1 2 3 4 5 6 6 cross 3 matrix. Okay, 6 cross 3 matrix. This whole thing is your x matrix. Okay, this is your x matrix. X will be 6 cross 3 matrix. Okay, now x transpose. What is the transpose? Transpose is when you are converting row with your column. That means xt will be your 3 cross 6 matrix. Okay, now we are multiplying it and we are taking the inverse. Okay, inverse, what is inverse? Inverse is adjoint of the matrix divided by the matrix mod. Okay, that is inverse. And into whenever we are doing this multiplication, 6 cross 3 into 3 cross 6, sorry, xt is first, so yeah, 3 cross 6 into 6 cross 3, that means xt into x, that means 6 6, that means your this matrix will be xt into x matrix will be 3 cross 3 matrix. Okay, 3 cross 3 matrix, x transpose will be 3 cross 6 matrix, so 3 into 3 cross 6, that means this whole thing will be your again 3 cross 6 matrix, and then y is your this matrix. Okay, this is your y, so y will be 6 cross 1 matrix, so your matrix will be your matrix will be 3 cross 3, and this is 3 cross 6, that means 3 cross 6 into 6 cross 1, that means your matrix will be 3 cross 1 matrix, and this 3 cross 1 matrix will give your beta value. And once you got that beta value, this beta value means this is your beta naught, that means your this constant, this is your beta 1, this is your beta 2. Okay, so you got this beta 1, beta 2 and beta naught, beta 1 and beta 2, you have x1 and x2, so beta naught plus beta 1, beta 1 is beta naught is 0.498, beta 1 1.517 into x1, that means 0.5, beta 2 is your 1.993 into x2, that means minus 1. So you will solve it and you will get this answer. 0.7365 will come here. I have approximated as 0.737, so option B is your correct answer. Yeah, so how it is 6 cross 3 matrix. Here you can see this table. Okay, so this is your 6 cross 3 matrix. There 1 2 3 4 5 6 rows and 3 columns, 1 2 3, so 6 cross 3 matrix. Okay, so this is a proper numerical question. Any doubt? Should I again explain it how to solve it?
Sir, like how did you narrow down to that equation beta equals to? X
This is
transpose
a
Yes,
X. Oh.
this is
yes,
a
sir. This is the only question I wanted to ask. How did we get this formula of beta?
this is a linear regression thing. You have to go through your maths thing. Okay.
Okay, sir.
Like in the lecture, it was like shown as beta cap equals to X transpose X whole
Yes.
inverse X transpose into Y.
Okay, beta
So
cap or beta whatever you can tell. Beta cap, that means are you taking transpose of it? If you are taking transpose of it, this will be like this will be here. It is yeah, here the answer will come 3 rows 1 column. There it will come 1 row 3 column. Okay. So should I again explain it how to solve it?
Yes,
Yeah,
sir, explain, sir.
yeah. Okay, again. So this is your this is your training data. Okay, you have two inputs x1, x2. You have one output, that is y. Okay, now you have to fit a linear regression model. And what is your model? Your model is y equals to beta naught plus beta 1 x1 plus beta 2 x2. And now they have given you for a unknown value x1 x2, that is 0.5 minus 1, what is your output. So how you will get the output? Once you know beta naught, beta 1, beta 2. Okay, so how you will get beta naught, beta 1 and beta 2? You have to follow this equation. Okay, this is your equation. Okay, now xt, what is xt? What is x? First x matrix, this is your whole x matrix, that is 6 column 6 cross 3 matrix. Okay, this is your x 6 cross 3 matrix. So this is your whole matrix, is your x matrix. Now transpose of it, transpose means we are converting our our rows into columns. That means our x transpose will be 3 cross 6 matrix. Okay, so you got x, you got xt. Now when you will multiply x transpose into x and inverse it, you will get a 3 cross 3 matrix. Now multiply this 3 cross 3 matrix again with this 3 cross 6 matrix, so that will give you a 3 cross 6 matrix. Why this y matrix? Y matrix is your this row. Okay, that means 6 cross 1 matrix. So you will get a 3 cross 1 3 cross 1 matrix. So this 3 cross 1 matrix is your beta value. Why 3 values are there? Because we have 3 variables, beta naught, beta 1 and beta 2. So when we got beta naught, beta 1 and beta 2, and we are putting x1 and x2, we will get the answer minus 0.737. Okay, everyone know how to find out inverse? Inverse is your adjoint of the matrix divided by modulus of the matrix. Okay, transpose, everyone knows how is transpose.
Yes,
Transpose,
sir. Yes, sir.
yeah, we are converting rows with columns. And multiplication, again you have to go through your matrix multiplication thing. Okay,
So sorry to ask you again, but बीटा नॉट एंड बीटा वन की वैल्यूज डिफरेंट कैसे होंगी, वो हम कैसे कैलकुलेट करेंगे? हमने बीटा के फॉर्मूले में डाली,
हाँ,
ठीक
yes
है सर?
please.
तो बीटा के फॉर्मूले में जब हम डालेंगे जनरलाइज जो आपने अभी बताया, तो उसमें
हाँ
जो फर्स्ट वैल्यू आएगी वो बीटा नॉट की होगी.
हाँ, बीटा नॉट की, या दिस इज बीटा नॉट. ओके, बीटा नॉट, बीटा वन, बीटा टू है.
देन बीटा वन कैसे कैलकुलेट होगी?
ये बीटा 1 होगा. आपके पास लास्ट में क्या आएगा? आपके पास लास्ट में ये आएगा, एक मैट्रिक्स आएगा,
ओके ओके, वील गेट अ मैट्रिक्स. ओके, आई गॉट
ए
इट सर.
बी सी. ओके, दिस विल बी योर बीटा नॉट, दिस
ओके
विल
सर,
बी योर
नाउ आई गॉट.
बीटा 1, बीटा 2.
ओके, थैंक
Sir,
यू सर.
sir, regarding this, I have one more. Like in the lecture, this entire thing was covered under EP, that is expected prediction error.
Okay,
Can you please like give a small definition about EPE, expected prediction error?
okay,
Because in the
next lecture I can cover if there is more doubt in this. Okay,
okay, okay.
okay. But this question you got right, how to solve this question that you got right, everyone?
Yes sir.
that
Yes,
is that is
sir.
the
Yes,
main
sir.
thing. So you got this or not? How to solve this question? Because similar question will be your assignment. Can you do
Okay.
this or not?
Yes, sir. Yes, sir.
Everyone, right? We need to do such matrix multiplication etc. in NPTEL exam too, sir. I am just a TA. I don't know what type of question will come, but in this you should know the concept how to solve. Definitely they will not give that big question, so no need to worry. But you should know how to solve. That is the most important thing. Okay. Okay. So let's move on to the next question. Consider the following dataset using our nearest neighbor KNN regression model with k equals to 3. Predict the value of y at x1 x2 0.5 minus 1. Use the Euclidean distance to So this is the question. Okay. So now how to solve it again? This is your x1. This is your x2. Okay, and this is your y. Now k nearest neighbor, how we solve this k nearest neighbor thing? We are given our unknown input. Okay, that is x1 x2. We have to find the output at this value 0.5 and minus 1. K nearest neighbor means we will first detect this point 0.5 and minus 1. So where will be our 0.5 and minus 1? This is our 0.5 and minus 1 will be this. So this is our point. At this point we have to find this y value. Okay, but we don't have a y value for this point, but we have y value for all this point. Okay, y value for all neighbor points. Okay, so k nearest neighbor, k equals to 3 means we will take 3 nearest neighbor. So what is the 3 nearest neighbor neighbor to this point? You can see this is a point, that is this is point minus 0.5 comma 0 minus 0.5 comma 0. This is a point this is a point. Okay, minus 0.50. This is one neighbor, nearest neighbor. This is one neighbor, 0 comma minus 2, and the nearest neighbor is minus 1 comma minus 0.5, right? Minus 1 comma minus 0.5. These three are the nearest neighbor. What is the output of the nearest neighbor? For this neighbor the output is this, for this neighbor the output is this, and for this neighbor the output is this. Now we will sum the three, we will take the average of this three, and that will be your answer. Okay, so again this three are the nearest neighbor, 0.5 comma 0.5 comma this is your nearest neighbor, minus 1 comma minus 0.5, minus 1 comma minus 0.5, this minus 0.5. Okay, minus 1 comma minus 0.5, minus 1 comma minus 0.5 comma 0 minus 0.5 comma 0 and 0 comma minus 2. This three are the this I think this is minus 0.5, right? So these are the three neighbors. These are the three predicted values: minus 1.947, minus 0.391, and minus 3.451. We will take the average of this three, mean of this three, sum all three and divided by 3. So the average will come minus 1.930. So option C will be your correct answer. How to solve using distance formula? Distance formula means you should see which is your nearest neighbor. Okay, so how you can find out? You can find out by Euclidean distance. Like if you take the Euclidean distance of this point and this point, the value will be large, but if you will take the Euclidean distance of this point, the value will be small. So what you can in practical, what you should do, you should find out Euclidean distance for all the point. If you cannot find out by visualizing, okay, visualize, here we can find out by visualizing that these three are our nearest neighbor to this point. But if you cannot visualize, what you have to do, you have to find out Euclidean distance. What is Euclidean distance? Euclidean distance is square root x2 minus x2 minus x2 2 minus x2 2 square minus x1 1 minus x1 1 square. This is your Euclidean distance formula. So you first sorry, plus is there. You first have to find Euclidean distance for each point, and by that you can find out which is the nearest neighbor. The value that will become less, that you will consider as the nearest neighbor. The value that will come more, you will not consider as your nearest neighbor. So that is the concept of that Euclidean distance. But here you can only visualize it, so no need to find out Euclidean distance. Okay. So please explain it once again, how to solve using distance formula. I think distance formula is clear. Now again I am telling you k nearest neighbor. Okay, k nearest neighbor is, we are finding the output with help of neighbor. Okay, the how we are finding the output with help of neighbor, and how many neighbor we should take, that depends on value of k. Here it is mentioned value of k is 3, so we will take 3 nearest neighbor. So first we will mark our point for which output we should find out. So 0.5 comma minus 1. So 0.5 comma minus 1, this is the point. Okay, now we will find out 3 nearest neighbor according to k equals to 3. So what are the 3 nearest neighbor? These 3 are our nearest neighbor. These 3 have some output. This point have some output y1, this point have some output y2, this point have some output y3. Now our output of this point let's say yp will be equal to y1 plus y2 plus y3 divided by 3. Okay, any doubt? Any doubt, please?
No, sir.
No, sir.
No, sir.
Everyone understood how to solve this? That is most important. Okay,
Yes, sir.
no doubt.
Yes, sir.
Okay. Sir, where I get this recorded video, kindly share the link, because it between only I've joined and missed the previous. Yeah. This will be you have SWAM portal, right? You are all logged in a SWAM portal. So in that SWAM portal, there will be a link called, I think, I don't remember the name of the link. That will be some discussion link or something like that. That link, when you will press it, you will be given a Google sheet. In Google sheet, in that Google sheet, you will find the link of this video, that whatever class I am taking. Second thing, you will find this slide. Okay, this too you will get it. Okay. Okay.
So there is one more question.
Yeah.
The question is, we got a mail in which they were saying there are 2 sessions. So both the sessions are same, or we need to attend both sessions?
One session you can attend.
One session. Okay,
Yeah,
thank you.
yeah. This is only for practice thing. Okay, so actually 3 TAs are assigned for this task. One TA, I think he takes class on Saturday. Okay, one TA and 2 TA are taking class on Tuesday. But again we have to change it. One will take on Monday, one will take on Tuesday. So you can find out what is your convenient time to join, and in any one class you can join. Okay.
Thank you, sir. And the class is seriously very helpful.
Okay. Yeah, it will be question answer session will be helpful, because whenever you will be doing assignment problems, right, you will not feel alienated. So that is the only motto behind this class. Okay.
Yes, sir.
Okay, so let's move on to question number 7. Consider the following statement regarding linear regression and KNN regression problems. Select the true statement. A linear regression requires training data points during inference. Okay. B, a KNN regressor requires training data points during inference. Okay. A KNN regressor with a higher value of k is less prone to overfitting. A linear regressor partitions the input space into multiple regions such that the prediction over a given region is constant. Okay, so any guesses for this? Okay, so I think someone is asking something. Sir, would increasing k means we will be getting more accurate value of y? Okay, we will discuss this in this question. Okay, C, everyone is telling C. Okay, A and C. So your correct option is B and C. Okay, a linear regressor requires training data points during inference. No, it does not require training data points. Let's see this. Let's see this problem. Okay, I have already explained you. Where is this thing? Yeah, let's see this. Okay, so this is your linear regressor. Okay, now linear regressor, we are told to find the input at this point. What is the predicted y? Okay, we are asked to find this. So for that we don't require training data, right? We only require this regressor only. That means we require a function. If we know this function f like x1 x2 xn, okay, we only required this function. That means we only required regressor. Okay, by that we can find out the output. Here we are not required the training data. Okay, so is it clear? For inference means whenever you are predicting the value of a unknown input, so that is known as inference. So for inference we don't require a training data, we just require a model. Okay, so this is the thing. Now what is in the case of knn, we have just solved this knn thing. Knn thing, in knn we required training data also, because knn means we have to find out our answer with the nearest neighbors. So nearest neighbors means we have to consider the neighbors also. That means we require training data in this case. Like in this case we cannot find without this 3 points. Okay, so we require training data for this point. But if it is a linear regression, we only required only x1 and x2. By that we can find out our predicted value. But here in addition to our training, in addition to our inference data, we also require training data. That depends on k. Okay, so this is the thing. So linear requires training data points during inference. This is a false statement, but this is a true statement. A knn regressor requires training data point during inference. So this is a true statement. A knn regressor with higher value of k less prone to overfitting. Overfitting means more error. So more will be the k, your model will less overfit. So this is also true. Now a linear regression partition the input space into multiple regions. That is correct, such that the prediction of over a given region is constant. That is incorrect. Prediction over a given region is not constant, right? Like if your linear regression is like this. Okay, so prediction over over this point and prediction over this point, this will be two different values. One will be this, one will be this. So this is two different points, right? So in same space we are not getting same points. So and this is also false. So your right answer is your B and C. Okay, so any doubt regarding this? Why it is not A? It is clear, right? Yeah, C is correct. Everyone was telling C is correct, so that is okay. You understood the difference between A and B, right? Yeah. Any doubt in this question? Anyone please ask? Okay, so let's move on to the next question. Okay, consider a binary classification problem where we are given a certain measurement from a blood test and need to predict whether the patient does not have a particular disease. Disease 0, class 0. Okay, class 0 means he does not have a disease, and class 1 he has a disease. Okay, in the problem false negative, incorrectly predicting the patient is healthy. False negative means he is healthy, but still the algorithm is giving that he is diseased. But other thing is false positive. False positive means incorrectly predicting the patient has the disease. Okay, false negative means he has disease, but the model is not able to predict it. False positive means he does not have disease, but the model is able to predict a disease. So which of the following is appropriate cost matrix for this classification problem? The row denotes the true class and the column denotes predicted class. Okay, so row denotes true class, means these are the row, means true, this thing is true class, and this is your predicted class. That is for all. This is true class, this is predicted. Okay, so which one of the following appropriate cost matrix for classification problem? So how we can get live session data? Which data you want, Ritu? Hello? Hello, am I audible?
Yes, sir.
Yeah,
This data,
Yes, sir.
this live session data.
live session data means this slide, right?
Yes, sir.
Yeah, you will find it
This
in that
session.
swam portal. Okay, swam portal, you will be given a link called, I think, a discussion or something. Okay, in that link you will find a Google
I
sheet.
just check it out, sir, but there is no link, no such link.
As of now there is no link because we are just taking the class. You can see it tomorrow or day after tomorrow. Okay.
Okay, sir. Thank you.
Okay. Okay, so yeah, so this is a very good question actually. This you have to use your brain. So there are two incorrect prediction. Okay, one is false negative and there is false positive. Okay, now uh, which one is good out of false negative, false positive? Yeah, both are wrong. Both are wrong. I admit both are wrong, but which is good? Either false positive is good or false negative is good. What do you think? False negative means the patient has a disease but the algorithm is not predicting disease. Okay. False positive means the patient does not have a disease but it is predicting. Yeah, false positive is good or bad? Yeah, false positive is good, right? Yeah, false positive is good, false negative is bad. Yeah, very well told that false positive is better and false negative is not better. Okay, so see, this is called this you are seeing, this is called as confusion matrix. Okay, confusion matrix, there are 4 rows. Okay, there are 4 rows. This row is called actual. Okay, this row is called predicted. Okay, now if your if you have a disease, it is predicted, so this is called as true positive. Okay, true positive, that means 1. If your if you do not have disease, algorithm is not predicting, this is called 0, that is true negative. Okay, there are two things. Okay, this is called true positive, this is called true negative. So these two are right outcome, but these two are false outcome. This is what you have a disease. This is yeah, this is you don't have a actual predictor. Okay, so let's say this is disease, this is D, and this is ND. Okay, this is D and this is ND. D is disease and D is not disease. Disease means true positive. Disease non-disease means non-disease means true negative. Okay, now we have two irregular things. One is true positive, true negative. True positive means yeah, true positive, false positive. False positive means patients does not have a disease but the algorithm is predicting disease. Okay, so this is your true positive TP and this is your false positive. Sorry, this is your true positive, true negative, this is false positive and this is false negative. False positive means the yeah, sorry, I was confusing. Okay, let me make this again. Yeah, let's make this again. This is actual. Okay, this is actual, this is predicted. Okay, we have 4 classes, this. Okay, now actual will have disease, actual will have non-disease, ND. Predicted will have disease, predicted will have non-disease. So up to this I think clear to everyone. Now disease means true positive. Okay, true positive means truly positive disease. Okay, disease non-disease, sorry, non-disease non-disease, non-disease non-disease means true negative. This is true negative. So true positive we are always giving 0, and true negative, yeah, true negative we are giving a yeah, 0 0. Okay, true positive, true negative we are giving 0 to both, because we are not giving cost to it, because these are true prediction. Okay, now we have two things left. One is false negative and another is false positive. False positive, yeah, patient actually has a disease, but it is non-detecting disease. That means it is false negative, FN. Okay, now patient does not have a disease, but it is predicting disease. That means it is false positive. Now everyone told that false positive is better than false negative. Okay, false positive is better than false negative. So if we are giving a penalty, okay, these are two are 0, these two are 0. Okay, because we are not giving penalty, these two are correct prediction, but here we have to give a penalty. So here let's say we are giving x1 penalty. Now here we are giving x2 penalty. Now according to you, x1 is good and x2 is bad, right? So x2 we should give more penalty, x1 we will give less penalty. So let's give x1 1, let's give x2 100 penalty. Okay, so which one of this option? B is your correct answer. Sorry, it is telling D. Okay, why not B? False positive. Okay, actual, okay, which of the following first?
Excuse me, sir.
Which of the following? Yeah, please.
Sir,
About the
aren't B
cost.
and D analogous? Sir, because then it will mean that what we are defining, that is we can replace ND and D or D and ND. Here we are taking D and ND, so it is coming B is the correct answer. But if we take ND and D, then it would be D as the correct answer.
Okay, so what has been told in the question? Told in the question, patient does not have a particular disease. Okay, patient does not have a particular disease is class 0, and patients have a particular disease is class 1. Okay, so according to your question, you have to change it. Okay, now here false positive. False positive means this should be a false positive means the prediction is disease, but he does not have a disease. So this should be your false positive, and according to me, this should be your false negative, because here the prediction is negative, but actually it has disease. So this will be your false negative. So cost, false positive also receive a small but positive penalty. Okay, false positive receive a small but positive penalty 1, and here is 100. So according to me, B is your correct answer, but here why it is not telling which of the following. Row denotes true class. Okay, row denotes true class. This row denotes true class. That means actual is a right, and column denotes predicted class. Okay, so according to me, B is your correct answer. Here D is written, but according to me, B is your correct answer. Okay, you got it right. False positive we are giving less penalty. This false negative we are giving more penalty. Okay, any doubt? Should I again repeat this?
Sir, if we are taking ND as the first column and first row,
Yeah.
then we will get D as the correct answer. Here we are taking first row, first column as D, so we are getting B as the correct answer.
Okay, so you are telling NDSD, NDSD. Okay,
Then
ND
because false positive and false negative will be replaced.
false positive, false negative will be replaced. No, even if will be ND, and here will be ND, DND, DND. Okay, so ND, ND. So let's do this also. According to you, let's take this. Okay. So according to you, ND, D, ND, D. Right, this is your actual and this is your predicted, right? So ND means true. ND non-disease means true negative. Okay. Disease means true positive. Okay. NDD means predicted is your diseased. Okay, predicted is your diseased, but actually predicted is your non-disease, but actually he has disease. That means predicted is your non-disease. That means there should be predicted is your means it should be false, right? False positive. This is FP and this is FN. Still it is FP and FN, right?
Sir, in the second row, you have written false positive, but it should be false negative, no, sir? Because the prediction is not telling that we have a disease, but actually we have a disease.
Disease we are taking positive. Oh yeah. This should be FN. Right. This should be FN. Yeah. We are considered disease as positive, right? So that is why this should be FN. This should be FP. Yeah. Right. I just made a mistake. So here what we are doing is disease we are considering positive. Okay. So that is why this is the thing. So this will be FN. This will be FP. So according to this, D will be our correct answer. Okay, because disease we are taking it as positive, right? Non-disease we are taking as negative. Okay, is it clear? Okay. So is it clear to everyone what we are doing exactly? First statement is clear, right? That false positive is better than false negative. Second thing, we have to make a confusion matrix. Confusion matrix, how it is made? We have to take actual values one side, we have to take predicted value on the another side. Okay. Now actual value here we are actual value as rows. We have to take actual value as rows, and columns we have to take predicted value. Now non-disease we are taking it as a true negative, and disease we are taking it as a true positive. Now whenever disease is there, we are considered it as negative, right? Because disease is there, so that is why N we are writing, but it is a false prediction, so FN. Okay. Now why it is FP? Because here disease is there, so we are writing P, but it is a non-disease, so FP. So that is why FN and FP. So that I have made a mistake. I admit that I have made a mistake. So by this, D is your correct answer, because non-disease we are taking it as a negative, disease we are taking it as positive. Okay. Can we take no disease class as positive? Yeah, that you can also take. So by that also you can you will get the same answer. Okay. Okay, that is up to you, but that is the thing, whatever you are taking you have to be consistent, because here if you are taking non-negative means negative for non-disease, and here if you are making mistake, then mistake will happen. Okay. So everyone got to know how to do it, right? That is the main thing. Everyone got it, right? How to do this question? Okay, so let me move to the next question. Okay, so consider the following dataset with three classes 0, 1, 2, 0. This is again x1 and x2. This thing is not coming, I don't know why. X1, x2. Okay, x1 and x2, yeah, it has three values 0, 1 and 2. This is actually a classification problem that is converted into a regression problem, and we have three classes 0, 1 and 2. Okay. Where the variable y, okay, class level, yeah, it is already mentioned, y is a class level. Okay, using a knn, k equals to 3, predict the class level at the point x1 and x2, 0.7 and minus 0.8. Okay, so 0.7 and minus 0.8, so you can tell where is 0.7 and minus 0.8. 0.7 is here, minus 0.8 will be somewhere here, so your point will be here. Okay, what are the three nearest point? You should find out. K equals to 3 is given, So the three nearest point will be minus 1 comma minus 1 comma 0.5, that will be minus 0.5, that will be this point. Okay, here the label is not has not come because it is, I think, overshadowed. So this is the first point, minus 0.5 comma 0, minus 0.5 comma 0, minus 0.5 comma 0. That means here there will be a second point. Sorry, here is your first point. This is minus 1 comma 0.5. Okay, minus 0.5 and 0 comma. Okay. So here we have 0 comma minus 2. This is the third point. This is 1 point and this is 1 point. These three are the nearest neighbors. Okay, these three are the nearest neighbors, I think, right? Minus 1 comma 0.5, minus 1 comma 0.5, minus 1 comma 0.5. Okay, I think there is some error in this chart also, so you please see. So k nearest neighbor, again the same concept, you have to take three nearest neighbor. How you can take? You can take the Euclidean distance. Wherever there will be less Euclidean distance, you can take. Here according to me these are the 3 points. So whenever these are the 3 points, you will find out what is the prediction of these 3 points. So according to this, the prediction of these 3 points are 1, 0 and 1. So majority is 1. So 1 will be your correct answer. Okay, so option B is your correct answer. Okay, any doubt on this? K nearest neighbor, this is for classification. Regression we have already done. Classification, again you have to find out 3 nearest neighbor to this point. 0.7 comma minus 0.8. 0.7 comma minus 0.8 will be somewhat here. So according to me, these are the 3 points closest to this. Okay, these 3 points, you will find out what is the predicted output for this point, and you will average this, and you will find out average in case of regression. Classification, what you will do, you will find out maximum which point is coming, maximum which prediction is coming. So maximum prediction is coming 1. So 1 will be your answer for this point, 0.7 comma minus 0.8. So option B is your correct answer. Okay, so any doubt in this? Okay, so let's move to the last question. Suppose that we train two kind of regression model corresponding to the following equation: y equals to beta naught plus beta 1 x1 plus beta 2 x2, y equals to beta naught plus beta 1 x1 plus beta 2 x2 and beta 3 x1 x2. So you can see this this second one is your more complex model. First one is your less complex model. More complex model means less bias. Okay, less bias, more variance. Less complex model means more bias but less variance. Okay, this is the two things. Now what are the statement given? We have to find out the correct statement. On a given training data, the mean squared error of first is always greater than that of second. Very true. Mean square error is what? Bias. So first is your simpler model. So more the simpler model, bias will be more. So first is very true. So option A is correct. Second, B. First is likely to have a higher variance than second. So again that is first have more bias, so less variance. So this is false statement. Second is likely to have a higher variance than first. So yeah, second will be have more variance, less. So this is also true. If second overfits the data, then first will overfit. If second underfits the data, first will definitely underfit. So more more complex is the model. The more complex is the model, the more will be chances to overfit. Okay, so if second will overfit, second will underfit, the first will also underfit. Okay, so E will be correct. Why D is not correct? D is not correct because second if second will be overfit, then first may not overfit. But if second is underfit, okay, second is underfit, then first will definitely be underfit. Okay, so is this clear why E is there, why D is not there? D is not there because because if second overfits, then first will definitely overfit. That is not true, right? If second overfit, then first will not overfit, because second will have more bias, but second have less bias, so it is more prone to overfitting. But first has more bias, so it is less prone to overfit. Okay, so that is why D is incorrect. But if still second underfits, second will overfit, but in case second underfits, the first will definitely underfit. Okay, so E is correct. Okay, so is it clear what I have told? Why E is correct, why D is not correct? Is it clear? Okay, any doubt? Okay.
So will you repeat the question? I mean, explain the question again.
Question is we have two model. Okay, one is a linear model, one is a more complex like quadratic model. Okay, these two are the model. We have been given 5 statements. We have to say which are the correct, which are the incorrect. That is the question. So one by one we are seeing if it is right or wrong. Okay, so first statement, on a given training data set, mean square error of first is always greater than that of second. So first is your more simplest model. Simpler the model, bias will be more or error will be more. So option first is correct. Okay, option second, first is likely to have a higher variance than second. Is it true? First will have a more variance. That is not true, because first is a simpler model. The more simpler is the model, less is the variance. Okay, so that is why this is false. C option, second is likely to have a higher variance than first. Definitely second is a more complex model, so variance will be more. Now D option, if second overfits the data, first will definitely overfit. Second will overfit, that is true. In some case may happen second overfit, but that is not true that first will overfit. Why first will not overfit? Because it is a more simpler model. You remember this thing? Yeah, you remember this thing? You can see this. Which is the more simplest model? This is the more simplest model, or this is the more simplest model? This is the more simplest model, but this is overfitting. So if this is overfitting, so definitely it is not true that this is also overfit. This is not true, right? Because this is clearly
Yes, sir.
overfitting, but this is not overfitting. So that is why option D is incorrect. Now last option is option E. Option E is second underfits. Okay, second is a more complex model, still it is underfitting, so definitely first will underfit. Like it is telling, again I am explaining you by this example, like if this is underfitting, so definitely this will underfit, right? Because this is a more complex model, this is still underfitting, then this is also underfit because this is a more simplest model. So option E is correct. Okay.
Okay, sir.
Okay. Any doubt regarding this question? Okay, so by this I am ending the session for today. Okay.
Sir, I want to see the explanation of first, second, and third questions.
First,
Just,
second, and third question.
just I want to see the explanation.
Yeah.
Just, no, sec-
These are very simple question, and this
yes,
slide will be provided to you. So don't worry. Okay.
yes, sir.
This
Second
slide
one,
as well as this video will be provided to you.
second and third, sir.
Yeah. Second question. This is your second.
And now third.
This is your third.
So,
This slide will be given to you. Don't need to screenshot. I think you are taking screenshot or something. So no
yes,
need to
sir.
take screenshot. This slide will be provided to you.
Sir, I wanted to ask you that weekly only one session we have to join. This
Yes,
session will be
yes.
once
Yes.
only anytime.
Because see, all those 3 sessions they will they will cover more or less same type of things. Okay,
Okay,
same
okay.
type of things they will cover. So why you will waste your time in
Okay.
joining all the 3 sessions?
Okay. No, in the previous course, this was not a fashion actually. Only once it was covered. There was only one session.
Yeah,
Yes.
yeah, because this course you have more number of student, right?
Okay.
Here only you have seen that more than 100 people have joined, so
Okay. Yes.
that is why. Because machine learning, everyone wants to learn what is this machine learning is, so that is why
Exactly. Exactly.
3 session we have to take.
Yes. Thank you, sir. Thank you very much.
Okay, okay,
So,
okay.
so that means if we are attending today's session, we don't have to attend the Saturday session,
No,
right, sir?
no, no, no need to attend. You just in a
Okay, sir.
week you attend one session. You have
Okay,
you
sir.
will have 3 different lecturer. Like one day I will take, and 2 days another two lecturer will take. So you can probably see which one you like it, and then you can join it. Okay.
Especially your lectures on which days, sir? Monday or Tuesday?
My lecture will be Monday or Tuesday.
Monday.
As of now, it is Tuesday, but actually 2 Tuesday session are colliding. So that is why I think I will take on Monday. Okay.
Okay.
Next week I will take on Monday, I think.
Monday. Okay.
Yeah.
Okay, sir. Thank you, sir.
Okay. Okay, everyone. Bye. We will meet on Monday or Tuesday. Okay. Next week.